Hello friends, my name is Vivek Sharma. Today we can cover this interesting problem that's called find median from data stream, right? So in this problem we need to design a data structure that supports the following two operation, right? We need to have this method add num and find median, right? So whenever we will add any integer it from the data stream, it will keep adding using this method, and this find median should be able to return the median of all elements so far. So that's the design question that we need to solve here. And also on a side note, median is the middle value, right, in a sorted array. And if it is even, list size of the list is even, then there is no middle value. What does that mean? Middle value will be the mean of the two middle values if the size is even. If it is odd, then of course it will be the middle value, right? So there are two examples here. This is for the odd length, and median is 3, and here the median is 2 plus 3 by 2 is 2.5. So let's do this. Let's try to understand this problem from the whiteboard, right? So of course 2 from 2 comma 3, the median will be 2 plus 3 by 2, 2.5, we have already seen. And also 2, 3, 4, if it is there, then the median is 3, right? It's pretty straightforward. All right, so we are not going to repeat this. Now we are here thinking about the couple of things that we have been given in the problem, right? So one thing is the sorted array, right? So this list, right? So these values can come in any order. So but we need to have the sorted array or sorted list, otherwise we are not able to find the median. So that's the one clue in the problem itself. Now how we can sort the array, right? So in Java there is a one data structure called heap or priority queue, right? So priority queue is an API in Java that we can use, right? So that's also called as a heap itself. And now how we can use that priority queue? So priority queue, basically the idea is here to use the two priority queues. That's what we can use. And from where this idea came, right? So what's the intuition to use the priority queue? The intuition is basically this guy, right? So we need to first of all have having the sorted array. So either one way is like don't use the, if we don't use the priority queue, we need to do the sorting and then we need to manually do all these things, right? Or the other way is just to use the priority queue from the sorting perspective to solve the sorting problem, right? So that's the intuition to use the priority queue. Now the question comes like why we are trying to use two priority queues, right? And that's a valid question. So the reason to use the two priority queues is basically so that we can cut off some of the operations and we can make it a little bit faster. That's one argument. Another is basically with the help of two priority queues, it will be little convenient and easier to get the middle value. How? We will see from the example. Okay, so let's jump into it, right? So let's say my stream is 1 2 3. We will start from very small and then we will just try to understand this. And then let's say I have two priority queues, right? So let's say this is 1 2 3, and I am having two priority queues. One is low and another is high, right? So low priority queues, we can say like if we have to balance, let's say for example, if we give a little thought to this problem or this array, right? For example, if we write something like this, right? 1 2 3, I'm just hypothetically, I'm just making these numbers, right? So let's say this is one priority queue, this is another priority queue. What the observation is there, right? So another one observation is basically 2 is coming somewhere in one priority queue, and our intention is to get the 2 from any of the priority queue, right? So that we can get the middle value, right? So that's the idea. And how we can get that? We can get that in the, basically in the process of balancing these priority queues, right? So how we will be doing that? Let's try to balance these and then let's try to build our algorithm, right? So first is 1. Let's store 1 to the low priority queue. And low, basically we need to take both the priority queues in the reverse order. Reverse order means like one priority queue we need to take as the decreasing order and another priority queue we need to take in the increasing order. What is the reason of that? So that at least we can get the middle point somewhere, right? So that's the reason. So let's say this is like decreasing, or let's say this is like max heap, or this is like the min heap. Min heap means like ascending order and max heap is the descending order. Okay, and we will try to balance these heaps. Heaps here is the priority queue. Heaps are priority queues, right? So one we inserted in low, or let's do this. Okay, anyways, so one and we will pull this one from here and we will insert to high. Why we will do that? Because remember we were discussing we need to balance these priority queues. All right, now low is not having any element because we pulled one from here, right? So now low size is 0, then we will again pull from high and then we will put to the low, right? So that's how we will try to balance these priority queues, and we will see, okay, if the size is basically same, then we can pick the two middle values and then divide by 2. That will be the solution for the even list if the size is equal, right? If size is not equal, then what we are going to do, we are going to take the peak of one of the priority queue. Now which priority queue? Whichever will have the data, whichever will have the more size length, right? So for example, hypothetically we are having only one element, right? Then in this case one is our result, right? One is the median value, because the fact is here the length is odd, right? Here is only one element. Now let's consider the other elements as well. So let's go ahead with the 2, right? So 2, what we will do, we will be inserting to low, right? Why I inserted 2 in front of 1? Because it is the max heap, it is in the decreasing order, right? So, and we already know why we are doing one increasing and one decreasing, so that at least we can have the median value in the middle, right? That's the attempt and that's what we are trying to do. Now see, the high size is less than low size, so high size is 0 right now and low size is 2 because it's having two elements. Now what we will do, we will pull from low and we will insert to the high, right? So we will insert to the high, now 2, right? So now we will check, okay, low size, what is the low size? It is 1. And what is high size? That is also 1. It means they both priority queues are equal size. Then let's say hypothetically I am having only these two data, 1 and 2. Then I don't need to do anything. If the both size are equal, then what I will do, I will simply do 1 plus 2 by 2, and that will be 1.5 will be my answer in case I am having only 1 and 2, right? But here I am having 3 as well, so let's do that as well. So let's consider 3. Now insert 3 here in front of 1, right? So these guys are done, I mean they all be already pulled, so we have only 3 and 1. Okay, now high size is less than low size, right? Now what we need to do, we will pull 3 and we will insert to the high, right? Why I did after 2? Because it is the increasing order, it is the min heap, it is in the ascending order. All right, now I will check again the low size. Low size is only 1, right? And high size is 2, right? In that case what I need to do, I need to poll 2. Why I will poll 2 here? Because it is in the ascending order, so the peak will be 2, right? Because it is the sorting, it will be doing the sorting, and in because it is the min heap or in the ascending order, so always the smallest element will be on the peak, and similarly on the descending order the highest element will be on the peak, right? That's the property of priority queues in Java, or in general in any heap in any language, right? So what we did, we pulled this 2 and we inserted, we need to insert 2 here, right? So there is no space, but let me put it here, 2. Okay, so now we put 2 here, right? So now what is going to happen, now we need to find the median, right? So in that case basically we will return 2 here itself. 2 will be our answer, right? So in this case 2 will be our answer, we need to return 2. 2 will be the answer. So what we will do, we will try to keep balancing these priority queues. In after balancing, if the size is even, right, and they are equally distributed between both priority queues, then basically we will take the middle and divide by 2, right, both of the peak. But if the size is odd, then basically we will take the peak of one priority queue, and in this case we are taking the peak of max priority queue, that is the the name is low, but basically it is the max priority queue and then in the decreasing order. So the basically the median value will be on the peak. Now let's do this. Let's try to uh, uh, walk through one more example and then we will start writing the code. So let's say this is low. Okay, this is high, and similarly this is like max heap, and this is like high is min heap. All right, so let's start from 1. Okay, so I'm just taking a little bit more space. So 1 in the low, we put 1 to the low, and then we pulled from low and then we put on the high priority queues, right? So these are the priority queues, because high size, I mean by default we will put in the low and then basically we will put into the high in the attempt to balance these two priority queues. Now we will check, okay, low size has been lesser than higher, right? So then again we need to poll this and then we need to put in the low, right? So that's the final step, right? We will try to balance like one time and then we are done, right? We cannot keep doing the same thing. It does not make sense, right? If I keep polling and then putting here, keep polling, it does not make sense. So we need to have one attempt to balance these and then we are done, right? And if the size is odd, then this low will have the result on the peak, and if the size is even, then basically this peak and then hypothetically some other this peak, let's say 2 or something, then this will be the result, 1 plus 2 by 2, right, as we discussed earlier. All right, now let's do. So 2 will be in front of 1 because it is the max heap, right? We will poll 2, we will put here in the high priority queue. Why? Because it is in the ascending order, right? And then we will see, okay, low size is also 1 and high size is also 1, so no need to balance these, right? They are already balanced, right? Now we will take 3, we will put 3 here in front of 1. 2 is gone, right? So 2 is cross is gone, right? 3 is there. Now we will poll 3 and then we will put into the high priority queue. High is just a name, right? But in fact low is the max heap and then min is the high heap. High, it is just a name because low means like it's in the coming in the starting, and high it is coming after the low, right? So just the naming convention. Now we will check after putting 3 here, after inserting 3 to the high heap, we will check, okay, low size has been lesser than high. Then what we will do, we will poll 2, not 3. Remember, this is the ascending order, so on the peak will be 2, right? So 2 is the lesser than 3, so 2 we will poll and we will put here. Put means we will be inserting 2 here, right, like this. All right, so now let's take 4. So 4 we will be putting again here, right? Because it is in the descending order, max heap. And then we will poll 4, we will put here 3 and 4 here. And now the size, this is also 2 because 2 and 1 is only there, only the elements, other we already polled, right? So we don't need to consider the crossed ones, we need to consider only 2 and 1. So this size is 2, this size is 2, right? So we don't need to balance it again, we don't need to poll from here, we don't need to poll 3 from here, right? Right, now let's take 5. Okay, so in case of 5 we will insert here and then we will poll 5 and we will put here to the high. Okay, why I'm putting after 4? Because again it is in the ascending order, right? And then we will check, okay, what is the size of low? Size of low is basically 2 because it is having 2 and 1, only 2 elements, and this size is 3. So in that case what we will do, we will poll 3 and then we will put here, right, 3 somewhere. Okay, so 3 we will put here and then, right, and then that's it. I mean we already tried to balance it, right? And now we will check, okay, low size is greater than high size, then whatever on the peak, that will be the median. So in this case 3 is the our output, right? 3 is our output, so this guy is our output, 3. Okay, so this is the idea. If it is still not clear, let's try to convert the same thought in the code and then it might be little bit more clear. Okay, so priority queue integer, let's say one priority queue name is low, integer, and then high. Let's go ahead and initialize these guys. So new priority queue, a comma b, b minus a. What is this? This is the same as the compare method. B minus a will make sure that it is in the descending order. So this is like max heap, right, in our example. And high. And why we are taking the max heap and min heap, I already explained, like because we want to balance it, and the idea is to get the median in the middle of these two priority queues, right? Median means like they should be on the peak. If the size is even, then basically they will be on the peak of both the priority queues, and then we will take divide by 2 plus, we will plus or we will add both the peak and divide by 2 in case of size is even. But if size is odd, then basically our low priority queue will have the output on the peak, right? That's how we understood here. So let's go ahead and do the same thing here, priority queue. And if we don't do anything here, by default it will be the ascending order, right? So it will be the min heap by default. Now here we need to do the same thing, right? So low dot offer num, and then high dot offer low dot poll, right? That's what exactly we were doing here in these examples, right? That's what exactly we were trying to do, right? So we were just inserting in the one priority queue, and we are polling, and then we are trying to make the balance. And now again we are checking, okay, if now in after this, if low dot size, if it has been less than high dot size, then what we are doing, we are again offering to the low. Offering means inserting, right? So high dot poll, right? So that's what we need to do. All right, that's exactly we are doing. And once we are done with this add step, then what we need to do, we need to check the size of both the heaps, right? So for example, if low dot size equals high dot size, then what we need to do, we need to take low dot peak plus high dot peak and divide by 2. And because it is double, so just let's go ahead and do that 2.0. It does not make sense, I mean it is 2 itself, but it will just have the typecasting as a double, right? And then if size is not equal, then we can simply return low dot peak, and that's it, right? So low dot peak, as we have seen here, right? So in that particular case, 3 is our output, so it is on the peak of 3. It is on the peak of low. Low means max heap, right? So that's the very simple, straightforward couple lines of the code. Let's try to compile this if it is working. So looks like for this test case it is working. Okay, and time complexity wise it would be log n, and the space complexity would be n, because in these operations we are maintaining these queues, so internally it takes n space to do all these sorting and all. But log n, because we are here using only the insertion and offer and poll, so insertion and removal, and that complexity is only log n basically, right? So let's go ahead and try to submit this code, and let's see if it is working. So it looks like this is working fine. Another optimization what we can do, this is very minor optimization, but here we can see like high dot offer. So offer is login, and then again we are doing this login operation here. So rather than doing this, what we can do, we can just use the peak, and basically we can do poll separately. It will not I mean performance wise, uh, uh, it might not impact that much. But what I'm saying, like from the complexity wise, like for example this offer is basically log complexity, and then we are nesting again the log complexity, right? So what I did earlier, it was like this. So we are, what we are doing, we are we are basically unnecessarily nesting like log complexity and then inside again log complexity. Rather than doing this, basically just have the order of one. So peak is the order of one operation, and then do this separately, load dot poll, right? So this is like little cleaner, and the complexity wise also it will be easier to understand. Okay, this is the log complexity itself. And similarly here we can also do the same thing. So we can do peak and then here high dot poll. Okay, it might not it might not make any much difference in the runtime or all, but from the complexity wise basically we can explain this way, like this is like the better way, and this is like the cleaner way, because we are not nesting the log complexities, but what we are doing, we are using this log complexity, and inside this offer we are using only order of one, because peak is order of one, and then separately we are doing log operations. Let's quickly check for the compilation and also try to submit this one if it is working fine. So looks like this concept is working fine. The main idea, before wrapping or ending this video, the main idea was basically to find the median from the data stream. The reason we took this priority queue data structures to achieve that kind of the goal, that it is coming from the continuous data stream, right? So it is not like the static array or static data, but it is like some data stream that is coming, and that is continuous, that is coming, right? So it is like easier to have two priority queues, right? And then basically try to balance those priority queues and trying to find the median, right? So if we will try to balance the priority queues in the notebook or wherever in the whiteboard, then we will encounter this kind of a situation that one priority queue will have the output on the peak in case the size is odd. What does that mean? If they are not balanced, right? Then in that case size will be odd, the total array list size or stream size will be odd. Then in that case low will always have the peak result. So the result will always be on the peak on the max heap. If the size is even, then in that case basically what will happen, if the size is even, means the both the priority queue size will be equal, and then we can take the both the peak and then divide by 2. That's what we are doing if the size is equal right here. So hopefully this makes little bit sense, and it might be helpful for all of you. All right, thanks a lot, have a good one, bye.